In this example, we're going to be solving 2x over 2x minus 1 plus 1 over x equals 1 over 2x minus 1. So be careful that you don't cancel these out. You have to remember that this denominator is a binomial that cannot be separated. So the first thing that we're going to do is we are going to look for the LCD. Now there's nothing that can be factored here, so we can just go ahead and find the LCD without having to do any extra work. So I'm definitely going to need a 2x minus 1 as one of my factors in the LCD, but also an x. So our LCD is x times 2x minus 1. So let's go ahead and multiply every single fraction by that LCD. So we're going to have x 2x minus 1. And we're going to multiply that all by 2x over 2x minus 1 plus, and I'm going to get my LCD again, multiply that entire thing by this fraction, 1 over x equals, and then one last time for that third fraction, x and 2x minus 1, which is the LCD, times 1 over 2x minus 1. So I'm writing it this way, it's kind of hanging on the top because it's technically over 1. I'm just not writing over 1. So now what we're going to do is we're going to cancel out terms wherever we can. So let's focus on the first fraction. So in the first fraction we can cancel out the 2x minus 1's, and then all I have left is x times 2x. So I have 2x squared. In the next fraction, my x's cancel out, so all I have is 2x minus 1 times 1, which is 2x minus 1. Alright, and then in the next fraction, we have the 2x minus 1's cancel, and all we have left is x times 1, which is x. Alright, so what I want to do now is I want to go ahead and combine my like terms. Because this is quadratic, and I know that because the exponent, the greatest exponent is 2, I'm going to set all of this equal to 0 because I'm going to start factoring and then solve those two different equations to figure out what the possible x values are. So the first thing is I'm going to do minus x so that we can get that 0 on the right side. So I have 2x squared plus x minus 1 equals 0. Alright, so now we can go ahead and start factoring. Alright, so you can use your guess and check, you can use grouping, whatever you'd like to do, but you can go ahead and factor that. We won't go through factoring, we have already gone through that in the past, so I'll just go ahead and give you the exact factorization of the entire polynomial. So we have x plus 1 times 2x minus 1. So if we wanted to check this, I could just distribute and we would find out that this is the factored form of this trinomial. Alright, so now that I have it fully factored, I'm going to go ahead and set both of these equations equal to 0. So the first one is x plus 1 is equal to 0, and the second equation comes from the second factor, which is 2x minus 1 equals 0. So if I solve, I'm going to get x is equal to negative 1, and here I'm going to do plus 1 on both sides, and then I divide by 2, so I get x equals 1/2. So you have to remember that before we can call these our final answers, we do have to check and make sure that they're not extraneous. So let's go ahead and take a look at the original problem. So I'm just going to go ahead and write the two possible answers up here, since I'm moving so that we can see this original problem. Now if I plug in negative 1 into my denominators, we have to check and see if at any point the denominators become a 0, because we know that we're not allowed to divide by 0. So if I plug in negative 1 here, 2 times negative 1 is negative 2, minus 1 is negative 3. So we're all good there, we're going to be good here too. If I plug in negative 1, that's not a 0. So negative 1 is one of my final answers. Let's go ahead and check what happens when we plug in 1/2. So if I plug in 1/2 into this denominator, 2 times 1/2 is 1, and 1 minus 1 is 0. So we do have a 0 in this denominator if I plug in x equals 1/2. And so already, for that reason alone, that answer is discounted, right? It doesn't it's not actually one of our answers. All right, because when we plug it back in to check, we see that it doesn't actually solve the problem. So in this problem, the only answer is x equals -1. You don't even have to write that this is extraneous. You literally just completely ignore it. You don't even write it as part of your answer because it's not an actual answer. So just to review a little bit, what that's called is an extraneous solution. All right, so an extraneous solution is a proposed solution, so an answer that we get, but we have to check. And what happens is when we plug it into the denominator, it makes the denominator 0. All right, and so we know that that's not allowed. We cannot divide by 0, and so we do not count that as an answer. And what we call those types of answers are extraneous solutions.